Welcome to our deep dive into Selenium, one of the most popular test automation tools in the industry. In this video, we'll explore what sets Selenium apart, how it handles web element identification, dynamic content, pop-ups, and much more. Whether you're a beginner or an experienced tester, understanding Selenium's capabilities and best practices can make your automation journey smoother and more effective. Let's start by understanding the core differences between Selenium and other automation tools, and why Selenium has become a go-to choice for developers and testers worldwide. One of Selenium's biggest strengths is its broad browser compatibility. Selenium supports major browsers like Chrome, Firefox, Safari, Internet Explorer, and Edge. This means you can test your web applications across different platforms without worrying about browser-specific issues. In contrast, many other automation tools are limited to just one or two browsers, which can restrict your testing coverage. With Selenium, you gain the flexibility to ensure your application works seamlessly for all users, regardless of their preferred browser. Selenium stands out by supporting multiple programming languages, including Java, Python, C#, Ruby, and JavaScript. This versatility allows teams to write tests in the language they're most comfortable with, making it easier to integrate Selenium into existing workflows. Other automation tools often restrict you to just one or two languages, which can be a barrier for teams with diverse technical backgrounds. Selenium's language flexibility is a major reason for its widespread adoption. Another advantage of Selenium is its seamless integration with a variety of tools. Whether you need to connect with test management systems, continuous integration pipelines, or defect tracking tools, Selenium makes it easy. This integration capability streamlines the testing process, allowing teams to manage and track test results efficiently. In comparison, some automation tools offer limited integration options, which can slow down your workflow and make collaboration harder. Selenium benefits from a large, active community of developers and testers. This means you'll find extensive documentation, tutorials, and forums to help you solve problems and learn best practices. A strong community also ensures that Selenium stays up to date with the latest web technologies. Other tools may have smaller communities, making it harder to find support or resources when you need them. With Selenium, you're never alone on your automation journey. Identifying web elements accurately is crucial for reliable automation. Selenium provides several methods to locate elements on a web page, such as by ID, name, class name, tag name, partial link text, XPath, and CSS selector. This flexibility allows you to choose the most robust locator for each scenario, reducing the risk of flaky tests. Let's look at each method and see how they work in practice. The most straightforward way to locate an element is by its unique ID attribute. In Selenium, you can use the findElement method to quickly and reliably find elements. Since IDs are meant to be unique within a page, this method is both fast and stable. Whenever possible, prefer using IDs for element identification to minimize errors and improve test reliability. If an element doesn't have a unique ID, you can use the name attribute instead. Selenium's findElementByName method helps you locate elements like input fields or buttons that share a common name. This is especially useful for forms and group controls. However, ensure that the name attribute is unique or specific enough to avoid selecting the wrong element. HTML elements often have one or more classes for styling and behavior. Selenium's findElementByClassName method lets you locate elements by their class attribute. This is handy for selecting groups of elements, but be cautious. If multiple elements share the same class, you may need to refine your locator or use other strategies to avoid ambiguity. Sometimes you need to interact with elements based on their HTML tag, such as div, p, or a Selenium's findElementByTagName method allows you to select elements by their tag name. This is useful for broad selections, but you'll often combine it with other locators for more precision, especially on complex pages. When working with anchor tags, you might only know part of the link text. Selenium's findElementByPartialLinkText method lets you locate links using a substring of their text. This is especially handy for dynamic links or when the full text isn't predictable. Just be careful to avoid partial matches that could select the wrong link. XPath is a powerful language for navigating XML and HTML documents. Selenium's findElementByXPath method allows you to craft precise queries to locate elements, even in complex or deeply nested structures. XPath is especially useful when IDs or classes aren't available, but it can be more brittle if the page structure changes frequently. CSS selectors are another versatile way to locate elements in Selenium. With findElementByCSS selector, you can use patterns familiar from web development to pinpoint elements. CSS selectors are often more readable and faster than XPath, making them a popular choice for many testers. Web applications often feature dynamic elements that change or appear based on user actions or server responses. Selenium provides several strategies to handle these, including implicit waits, explicit waits, refreshing the page, and retrying element searches. These techniques help ensure your tests remain stable even when elements load asynchronously or change over time. Implicit waits tell Selenium to wait for a set amount of time when searching for elements before throwing an exception. This is useful when elements may take a moment to appear due to slow page loads or dynamic content. By setting an implicit wait, you give your tests a buffer to handle minor delays without failing prematurely. Explicit waits are more targeted, allowing you to wait for specific conditions, such as an element becoming visible or clickable. Using WebDriver wait and expected conditions, you can make your tests more robust by waiting only as long as necessary for the right condition. This approach is ideal for handling elements that appear unpredictably. Sometimes, dynamic elements only appear after a page refresh. Selenium allows you to refresh the page and retry locating the element. This can be especially useful for applications that load content in stages or after certain triggers. Just remember to use this technique judiciously to avoid unnecessary reloads. If an element is still not found, you can implement a retry mechanism. By looping through attempts and adding short delays, you give the page more time to load dynamic content. This approach, combined with waits, can significantly improve test stability, especially for highly dynamic web apps. Pop-ups, also known as dialogues or alerts, are common in web applications. Selenium provides several methods to handle different types of pop-ups, ensuring your tests can interact with or dismiss them as needed. Let's explore how to manage alerts, window pop-ups, iframes, and browser-generated dialogues. Alerts are simple pop-ups that require user action, such as accepting or dismissing a message. Selenium's switch to alert method allows you to interact with these alerts, accepting, dismissing, or reading their text. This ensures your tests can continue smoothly even when alerts appear unexpectedly. Some actions trigger new browser windows or tabs. Selenium's switch to window method lets you switch between windows, interact with elements, and close pop-ups when done. This is essential for testing workflows that involve multiple windows, such as payment gateways or third-party logins. Iframes allow a web page to embed another page within it. Selenium's switch to frame method lets you move into an iframe and interact with its elements. When finished, you can switch back to the main content using switch to default content. This is crucial for testing embedded content like ads, widgets, or third-party integrations. Some pop-ups are generated by the browser itself, not the web page. Selenium can handle these by switching to the appropriate window and interacting with its elements. After completing the necessary actions, you can close the pop-up and return to your main test flow, ensuring comprehensive coverage. Modern websites must look good on all devices. Selenium helps you test responsiveness by allowing you to set the browser's viewport size using set window size. By simulating different screen sizes, you can verify that your site adapts correctly to desktops, tablets, and mobile devices. This ensures a consistent user experience across platforms. With Selenium's set window size method, you can specify the width and height of the browser window. This allows you to test how your website behaves on different devices, from small smartphones to large monitors. By automating viewport changes, you can quickly identify layout issues and ensure your site is mobile-friendly. After setting the viewport, Selenium lets you interact with the website just as a user would, clicking links, filling forms, or scrolling. By repeating these actions across different viewport sizes, you can ensure that all interactive elements remain accessible and functional, regardless of device. To efficiently test responsiveness, you can use a loop to iterate over a list of viewport sizes. For each size, Selenium sets the window dimensions, navigates to the site, and performs the necessary actions. This approach saves time and ensures thorough coverage of all major device types. Visual validation is key in responsiveness testing. Selenium's getScreenshot as file method lets you capture screenshots at each viewport size. By comparing these images, you can quickly spot visual differences or layout issues that might affect the user experience on different devices. Selenium's Action Chains class allows you to simulate mouse actions like clicking, double-clicking, right-clicking, dragging, and dropping. By chaining these actions, you can replicate complex user interactions, ensuring your tests cover real-world scenarios. This is especially useful for testing interactive elements like sliders, menus, or drag-and-drop features. To simulate a mouse click, use action chains to identify the target element and perform the click. You can also chain actions, such as moving to an element before clicking. This approach ensures your tests interact with the page just like a real user, improving accuracy and reliability. Keyboard interactions are just as important as mouse events. With action chains in the keys class, you can simulate typing, pressing Enter, Tab, Backspace, and more. This is essential for testing forms, shortcuts, and any feature that relies on keyboard input. One of the strengths of action chains is the ability to chain multiple actions together. For example, you can move to an element, click, and then type text, all in one sequence. This makes your tests more efficient and closely mimics real user behavior, especially for complex workflows. Speed up testing. Selenium Grid allows you to run tests in parallel across multiple browsers and machines. By configuring your test framework, such as JUnit or TestNG, you can specify the number of parallel threads and run multiple tests or methods simultaneously. This drastically reduces test execution time and increases coverage. In your test configuration file, set the parallel attribute to tests or methods and specify the thread count to control how many tests run at once. This setup allows you to maximize resource usage and get faster feedback from your test suite, which is especially valuable in continuous integration environments. Selenium supports both local and remote testing. Local testing runs your scripts on your own machine, using browsers installed locally. This is fast and convenient for small-scale testing, but limited by your hardware. Remote testing, on the other hand, runs tests on a remote server, allowing you to test across multiple platforms and browsers without local installation. Each approach has its pros and cons, depending on your project's needs. Local testing is typically faster and easier to set up, especially for quick iterations or small projects. You have direct control over the environment and can debug issues more easily. However, you're limited to the browsers and operating systems available on your machine, which can restrict your testing coverage. Remote testing allows you to run your Selenium scripts on different machines, operating systems, and browsers without local installation. This is ideal for cross-platform testing and large-scale projects. The main trade-off is that remote tests can be slower and require a stable internet connection, but the flexibility and coverage are unmatched. Effective reporting is essential for tracking test results and identifying issues. Selenium integrates with several reporting tools, including TestNG, Extent Reports, Allure Reports, and each tool offers different features, from simple HTML summaries to interactive dashboards with charts and screenshots. You can also create custom reports tailored to your team's needs. TestNG is a popular testing framework for Java that provides built-in reporting. After running your Selenium tests, TestNG generates HTML reports showing test methods, pass-fail status, and execution times. These reports are easy to read and help you quickly assess the health of your test suite. Extent Reports is an advanced reporting library for Java and Net. It generates detailed HTML, PDF, or email reports with charts, graphs, and screenshots of test failures. This level of detail helps teams quickly identify and address issues, making Extent Reports a favorite for comprehensive test reporting. Allure Reports offers visually appealing, interactive reports accessible via a web interface. Supporting multiple programming languages, Allure makes it easy to explore test results, view trends, and drill down into failures. Its interactive nature helps teams collaborate and resolve issues faster. ReportNG is a simple reporting tool that generates clean HTML reports for TestNG tests. It provides a straightforward summary of test results, including methods and execution times. ReportNG is ideal for teams that prefer minimal, easy-to-read reports without extra complexity. For teams with unique needs, Selenium allows you to create custom reports by writing code to generate summaries, charts, or logs based on test results. This approach offers maximum flexibility, letting you tailor the report layout and content to fit your workflow and stakeholders. In summary, Selenium's versatility, broad compatibility, and strong community support make it a top choice for test automation. By mastering its locator strategies, handling dynamic elements, managing pop-ups, and leveraging powerful reporting tools, you can build robust and maintainable test suites. Remember to choose the right tools and techniques for your project's needs, and always keep learning to stay ahead in the fast-evolving world of test automation. As web technologies continue to evolve, so does Selenium. Staying updated with the latest features and best practices will help you maintain effective automation strategies. Engage with the Selenium community, experiment with new integrations, and keep refining your skills. With the right approach, Selenium can help you deliver high-quality software faster and more reliably.